Today I'm going to talk about pipelining. My presentation will be on stage 2, which is decoding, and we're going to cover some basic elements of decoding and show you exactly how it fits in the pipeline process. Here's the overview of the process of pipeline. This is showing the 5 stages. As I said earlier, I'm going to cover just the decode today. So decode is stage 2 of the pipeline process of operations. It's responsible for the instruction fetch, instruction decode, as well as the execution registers. It decodes opcode bits. It sets up control signals for later stages. It reads the input of the operands for register files. It's specified by decoded instruction bits. And it writes the state to the pipeline register of the instruction decode execution register. So those elements you have is the opcode, the register contents, your PC plus 1, which is your increment PC, and control signals for your opcode and destination register. And here's a diagram to give you a picture of exactly how this particular stage works. It's coming from your first stage, which is the fetch. It carries through the decode, the second stage, and it goes through your third stage, which is your execute. And those are all the different elements you show them. You have your registers file in between, different registers, the destination register data, many inputs. So especially for a 32-bit register file in this case. So these are the elements in order to do decode. Decoding is pretty easy. You know, you're just passing on the opcode, and you're letting the other stages figure out their own control signals for the instruction. So this is pretty easy. You know, as you're going through, you're writing to those registers. To the next register, pipeline register. So data forwarding in this case, this is also known as bypassing. Data forwarding takes the result from the earliest point that exists in any of the pipeline state registers and forward it to the functional unit. So in this case, let's use the arithmetic logic unit that's needed in the next cycle. So this forwarding can achieve a CPI of 1 even if the present of data dependencies. So in order to achieve data forwarding, this is pretty much how you do it. You can add muxes to the inputs of the functional unit, such as the ALU. You can connect the read-write data in the execute memory or the memory write-back pipeline registers to either or both of the execution stage registers at the ALU mux input. Or you can add the proper control hardware to control the new muxes. So in order to get data forwarding, these are a couple of things that you can do. Branch prediction. This resolves a branch hazard by predicting which path will be taken. You can execute under that assumption. It flushes the wrong path instructions from the pipeline and fetches the right path if wrong. In order to achieve branch prediction, you use additional adders to calculate a target as soon as the branch instruction is decoded. We need a branch target buffer as well. It is a hardware mechanism that aims at reducing the stall cycles resulting from correctly predicted taken branches to 0 cycles. Another way of achieving branch prediction is to perform dynamic branch prediction. This is a hardware-based scheme that utilizes runtime behavior branches to make dynamic predictions. Some of the issues in trying to do some execution or working with test cases with this particular stage of the pipeline is ensuring that you have the register files and the right number of bits in it. This is a thing when you're compiling, because you have to use instructions, or you have to use the data that's coming in from the fetch into your register files and instruction bits incrementing your PC, and then also writing to the next pipeline register, and ensuring that you have the right data. So you have about 3 different files that you have to compile and ensure that they are coinciding or coming together in order to compile properly. So some of the issues that I've had is just trying to get the making sure the registers, when they compile, that they see each of the different elements that are coming out of that. So there were some couple of issues there, and then also ensuring that you don't go into the data forwarding or branch prediction in this case or this scenario. There's adding those particular codes in that. So there's a couple of issues there. So those are things that I kind of look forward to. Decoding is easy in this case, but you got to make sure you pass on the right opcode, ensuring that you have the additional, making sure that you have all the different elements from the other stages coming in, and then also ensuring that you don't have the instructions or the registers reading, before it writes to the next stage. So those are a couple of issues there. So that concludes my presentation. Here are a couple of references that I use in order to get the information and putting this together. So I just talked about decoding, giving you the stage 2 of the pipeline register process, and again, these are my references.